So hello everyone. So today in this particular video I will actually show you one of my tool that I have actually built basically while I am actually learning CNN architectures, convolution neural networks. So when I actually get into this how CNN actually work behind the scene, and I thought maybe I can create a tool that might help me personally to visualize what is actually happening behind the scene in a CNN. So this is the tool basically, and I have a GitHub repo for this tool also. So it's called Kaushik24/convolution visualizer, and you can check out this GitHub repo. And if you click this link here, it will redirect to this you here. So the tool is called interactive convolution visualizer, and it actually demonstrate how various convolution parameters affect the shape and the data dependencies between the input, the weight, and the output matrices. So basically whenever you are actually using any convolution on top of any kind of image, you have to provide some initial like a random matrix, and based on that you are creating convolution one by one, and you are getting the maybe the maximum number from your matrix, and you pull that number. It's called max pooling actually, and there are different kinds of pooling also right there, which is average pooling as well. So here if you look into the input size, like you can adjust the matrix, input matrix. So this is a random input matrix which is 7 by 7, and we have a weight matrix. Basically you can say it's a kind of filter, and the kernel size equals to 3 by 3, and we have a zero padding. By the way, you can also adjust the padding as well. So so you have all the options there, and you can also use the dilation parameter, and you can also add the stride parameter. And this is my input matrix, which is 7 by 7, and this is my weight matrix, which is 3 by 3, and the output matrix will be 5 by 5. So there is a like math there. So if you have input matrix m by m cross n, and you have weight matrix which is also a comma b, then you can also get the output matrix. I'm not going to that like mathematical formula right there. I just want to show you that how my tool actually interacting. So here you can see the interaction is very nice here. So let me click on the animate convolution. So if I click this, here you can see like 3 by 3 matrix are going one by one, and it produces this particular corresponding matrix. So you can see, like, based on your weight matrix and input matrix, how the output matrix is being created, and you can visually see this. Also you can like maybe reduce the animation speed if you want to track like what is happening there. And if I click there, so here you can see now it's slowing, like showing the animation very slowly, and you can get like how these numbers are getting from there, right? And you can also stop the animation. Let me stop this, and if you hover into any of the output, so for example this 7 output comes from, if you take the input matrix which is blue colored 3 by 3, and if you multiply it to the weight matrix, you will get to this output matrix. So this is how actually it's work. And here you can also add the padding. So if you use padding equals to 1, so here you can see there is a 0 padding into the input matrix. And you can also adjust the dilation parameter, and also there is also a stride button. So you can increase the stride as well. So if you update this, here you can see based on the all of the input sizes, your animation is being actually updated. And this is how it actually work, and you can try it. Even there is another option. I actually added this feature recently, which is called amnist digit image. So what I have done is that I have taken the 28 by 28 pixel image, and based, so these 28 by 28 pixel image, they have their corresponding pixel values, right? So what I did is that I just added those pixel value as a matrix. So let me show you. If I select the amnist digit 28 by 28, and if I keep everything, for example, padding 0, stride 1, maybe stride 0, yeah. So here I can also adjust the dilation parameter. And oh yeah, so sorry, you have to also add the input size as well. So it is 28 by 28. So here you can see this is the actual amnist data set, and if I reduce the padding, here you can see there is no padding right there. So this is the input matrix, which is 28 by 28, and this is the weight matrix, which is 3 by 3, and this is the whole output matrix, which is 26 by 26, that is being generated. And here you can see after the convolution, it actually recognizes the patterns from these digits. So this is the digit 5. So it has a horizontal line, also a vertical line. So you can see this section, it actually captures the horizontal line, and also there is also vertical line. So in this section here you can see the vertical line. So see how CNN are actually capturing patterns out of your images. So based on this visualization, you can interact with all of the individual pixel, like based on the pixel how it actually generated, and you can get the feel out of it, like how the actual CNN actually working behind the scene. And if you click any of the, like if you click any of the pixel values, you will see these are the corresponding values that are getting from the convolution operation. So if I start the animation, let me increase the animation speed, as the input matrix is 28 by 28. So if I click animate, here you can see based on the weight matrix and the input matrix, all of my output matrix has been changed. So see, and this is how it actually work. And do let me know in the comment section what is your experience, and thank you. Bye.